Alright, this is lesson 37, factoring sum and difference of cubes. This is day 2. So we're doing the same concept except we're applying it to larger problems. Okay? So, sometimes we use a concept in math to break down bigger problems. So like if there's an issue where you have a big problem and you're like, okay, I don't know how to deal with that. Sometimes you could say, oh, I see a pattern and I could break it down to a smaller problem. Okay? So, or smaller pockets. So, that could be a way to deal with it, dealing with problems in chunks. So this is a way we do that. A specific way in math, at least. The steps are the same as yesterday. So the big thing you need to know is the factored forms. Okay, you need to memorize these right here, okay? You have to memorize those on the test. So, really easy to memorize. It's really easy not to also. If you don't memorize them, then you're kind of stuck, okay? So make sure you memorize those, because I will not provide those. Okay? Here we go, number 1, factor. Alright, so number 1, we're noticing that the exponent is the 6th power. 6th power, right? Kind of scary, right? We haven't seen anything like that yet. If we had a problem where it was like equal to 0, that means there would be 6 answers to this problem. 6 answers, wow, kind of scary, right? So, since we don't have 6 answers, or we're not doing a solving problem, we just need to factor. We need to think about how do we factor this, okay? From yesterday's lesson, I remember recalling that we have to look for cube roots, okay? We know that the cube root of 27 is 3, right? Because 3 times 3 times 3 is 27, right? And then the cube root of m to the 6th, well, the cube root of m to the 6th is m squared, right? So we know that all of this is like saying 3m squared raised to the 3rd, right? Because we know that by the power property, m squared raised to the 3rd is 6, right? You follow me so far? So this is our a, and then our b, cube root of 8 is 2. Because we know 8 could be represented as 2 cubed, okay? So that means our a is going to be 3m squared, and our b is going to be 2, okay? So just like yesterday at this point, once you identify a and b, you just follow the form the factored form. So since there's a minus sign here in our original problem, we're going to take our a minus b times the quantity of a squared plus ab plus b squared, and then we're going to put parentheses around that, and then we go a minus b, so it's 3m squared minus b, our b is 2, times the quantity of a squared, which is 3m squared, which is 9, m squared times m squared is m to the 4th, plus a times b. A is 3m squared times b is 2, so it's going to be 6m squared. And then b squared is going to be 4, okay? And that's it. Can't do anything else. Now, if this was a solved problem, there would be a 0 equal to 0 here, and then we would use a 0 product property. But we're not doing that today. We're doing that later. But this is your factored form, okay? So again, what did I do just now? Starting from the beginning, what I ended up doing is I noticed it was the 6th power, and I asked myself, are there any cube roots of the first and second term? We know that the first term is like saying 3m squared raised to the 3rd power, and then the second term is 2 cubed, right? So a is equal to 3m squared, b is equal to 2, and then I just used the form that we learned yesterday, so it's a minus b times a squared plus ab plus b squared. And then you just substitute, right? So writing it down, 3m squared minus 2, and then a squared is going to be 9m cubed plus a times b, which is 6m squared, and plus b squared, which is 4. Okay, so that's number 1, right? Pretty simple, just a little bit bigger today. Number 2. We got 648x to the 7th power plus 3x, okay? On your steps, it always asks for you to check your GCF, okay? So, are there any GCFs here? Well, I'm noticing that in both of these, there is x to the 7th and x to the 1st power, so I could actually take away or factor out an x out of this. And I'm going to say that 3 is going to really go into 648, so I could factor out a 3 too. So I would check on my work. If I were as a student, I would see if I could divide 648 by 3. Now I know I can. So 648 divided by 3 is 216. Okay, and then the factored form would leave 216x to the 6th plus 1, right? Because we know that 3 times 216 is 648. And then x times x to the 6th is x to the 7th, right? 3 times 1 is 3, right? And then x times 1 is x right here. So we're good. We factored it correctly. So the first step here on the second one is take out a GCF, right? Like I talked about yesterday. And then, just like on problem 1, there's 2 perfect cubes here, right? We know that 216, the cube root of 216 is 6, right? And the cube root of x to the 6th is x squared. Okay? And we know that to figure out this, always just divide, what's 6 divided by 3? 2, right? That's the easy way to figure that one out. Alright, cube root of 1 is just 1. And we have a plus sign here, right? So if this is the case, then our factored form would be, we take the GCF from the first step, so it's going to be 3x times a plus b, which is 6x squared, plus 1, times a quantity of a squared, which is 6 squared, which is 36. X squared raised to the second power is x to the 4th, minus a times b. A times b is just 6x squared, plus b squared is just 1. This is your final answer. Okay. Again, we're working on this like breaking it down into chunks, okay? So don't go too fast, but we have a lot of tricks we've learned already so far since Algebra 1 and this class with figuring out GCF, figuring out how to factor. And there's going to be even, sometimes at this step you could factor more, but at this step we really can't factor anything, okay? This is not a difference of square, this is not a quadratic or an easy quadratic to simplify. Yes? Question? Okay. Alright. So what I'd like you to do, let's have the 2s start today. 2s will tell the 1s about number 1, and then 1s tell the 2s about number 2 after that. Ready, set, go. Okay, good. So I heard people say the cube root of this first term is, 5m squared, right? And when in doubt, you just take m to the 6th, divide by 3, right? What's the cube root of 27, everyone? 3, good. Okay, so 3 cubed. So we know what our a is and our b is, and then we're going to follow the form of a minus b. Everyone's doing this on their iPads or paper. Everyone's working though. They're doing this one together to a point, and then I'm going to release you. A squared plus ab plus b squared is this particular problem. Okay. Alright, so now I'm plugging in my a and b. We know a is 5m squared minus b, which is 3. A squared is 25m to the 4th plus a times b, which is 15m squared plus b squared, which is, well, I'll leave it there. Finish it up. Finish up your answers. I left most of the work there. You just got to do like one simple little thing to finish it, okay? Go. This is plus 9, okay? Good. And I think we're going to get this fine. I'm going to jump up to the next one. Let's go up to 5, okay? I think you're getting it. Number 5, okay? Before we start number 5, are there any things we could factor out of 5? M, right? Because what if I factor out an m? We could take out, if we factor out an m, we have, what's going to be inside these parentheses? 8m to the 6th power plus 1, right? You got it? Okay, and then what is the cube root of 8m to the 6th? 2m squared. Okay, cube root of 1 is?
1.
Okay, good. So do this whole problem and don't forget that GCF at the beginning. Ready, set, go. Wrong, okay? All of you had the GCF in the right place. Then we have this one, we have to have a plus b, so it's going to be 2m squared plus 1. That's the first one. I think everyone got that part right. And then over here, 2m squared. What's 2 squared? 4. M squared is m to the 4th. Then we got 2m squared times 1 is going to be, we put a minus sign there first, of course, it's going to be just 2m squared. And the 1 squared is just 1. Okay? You got it? Alright, last one. The last one I wanted to show you, this one's a little scary, right? Because there's a negative sign there. I wanted to show you a trick. Whenever you see two negatives, and those are the only thing, or the only operations in front of numbers. For example, number 6, we have a negative sign here and a negative sign here, right? We don't like that, so, I mean, I don't like dealing with negatives. I think they're kind of scary, right? So, and then I'm noticing there's an x and an x here. So what I'm going to do is just factor out a negative x, okay? Because I'm factoring out a negative sign and I'm factoring out an x, right? So we know that the negatives will turn into positives, so negative times a positive x to the 6th is going to be negative x to the 7th. Negative x times positive 216 is going to be negative 216x, right? So that's the first step. Finish it off. Ready, set, go. In this example, we know that x to the 6th is x squared raised to the 3rd plus 6 to the 3rd. We got negative x, all of that, right? So this is going to be negative x times the quantity of x squared plus, I'm sorry, this is supposed to be a minus, x squared minus 6 times the quantity of x to the 4th plus 6x plus 36. Okay, that's it. That's your final answer. All right, so that's the factored form. So you'll need this, these skills for the future, I think. Huh? Oh yeah, this is supposed to be 6x squared. Yeah, thank you. Absolutely right. Yep, good job. Okay, so you'll need this skill for the future, and that's it. This concludes our lesson. Please clean up anything on your iPads.